Welcome back to JVM Internals Crashcasts. I'm your host Sheila, and today we're diving deeper into JVM security. We're currently in our Beyond Expert season, exploring advanced topics and future directions of the JVM. In our last episode, we discussed security managers and policies. Now, we're moving on to a crucial aspect of JVM security: bytecode verification. Joining me as always is our JVM expert, Victor. Victor, are you ready to demystify bytecode verification for our listeners?
Absolutely, Sheila. I'm excited to unpack this critical component of JVM security. Bytecode verification is a fascinating topic that plays a vital role in ensuring the safety and integrity of Java applications.
Great! Before we dive in, let's start with a quiz question for our listeners. Here's a tricky one. If a malicious actor modifies a Java class file to include invalid bytecode instructions, at which stage would the JVM most likely detect and prevent the execution of this code? Think about it, and we'll reveal the answer at the end of the episode. Victor, any thoughts on this question without giving away the answer?
That's an excellent question, Sheila. It really gets to the heart of JVM security. It makes our listeners think about the different stages of code processing in the JVM and where security checks might occur. I'm looking forward to discussing this in detail as we explore bytecode verification.
All right, let's start with the basics. Victor, could you explain what bytecode verification is and why it's important?
Certainly. First, let's quickly explain that bytecode is the intermediate representation of Java code that the JVM executes. Now, bytecode verification is a crucial security process in the JVM that checks this Java bytecode for correctness before it's executed. It's essentially a gatekeeper that ensures only safe and well-formed code runs on the JVM. This process is important because it prevents malformed or malicious code from causing harm to the system or compromising security.
That makes sense. So, it's like a security checkpoint for code. Can you walk us through how this verification process works at a high level?
Great analogy, Sheila. Yes, you can think of bytecode verification as airport security for your code. Just as airport security checks passengers and their belongings before allowing them onto a plane, bytecode verification examines code before it's allowed to run on the JVM. The process happens in several stages. 1. File format checking. 2. Bytecode parsing. 3. Type checking. And 4. Data flow analysis. Each stage looks for different types of issues or potential security risks.
That's fascinating. Could you elaborate on these stages? What kind of issues does each stage look for?
Certainly. Let's break it down. 1. File format checking ensures that the class file adheres to the correct structure and format. 2. Bytecode parsing verifies that all bytecode instructions are valid and well-formed. 3. Type checking confirms that operands are of the correct type for each instruction. 4. Data flow analysis checks for issues like accessing uninitialized variables or violating access control rules. Each stage builds upon the previous one, creating a comprehensive security check.
I see. It sounds like a thorough process. Are there any common issues or vulnerabilities that bytecode verification typically catches?
Absolutely. Some common issues include stack overflow or underflow attempts, illegal typecasting, accessing arrays out of bounds, violating access control, like accessing private members illegally, using uninitialized variables. These might seem like simple programming errors, but they can be exploited for malicious purposes if left unchecked.
That's really interesting. It seems like bytecode verification catches both accidental errors and potential security exploits. Are there any challenges or edge cases in bytecode verification that developers should be aware of?
Great question, Sheila. One significant challenge is balancing thoroughness with performance. Bytecode verification needs to be comprehensive enough to catch all potential issues, but not so intensive that it significantly slows down program execution. An interesting edge case is subroutines in bytecode. These were used for efficient compilation of finally blocks in older Java versions. Verifying subroutines is complex because the same code can be called from multiple places with different stack states. Another challenge is verifying code that uses complex generics or lambda expressions, as these can lead to intricate type relationships that need careful checking.
That's fascinating, Victor. It really highlights the complexity behind ensuring code safety. Now, let's talk about real-world implications. How does bytecode verification impact Java developers in their day-to-day work?
In most cases, developers don't need to worry about bytecode verification directly. It's a behind-the-scenes process that the JVM handles. However, understanding it can help developers write more secure and efficient code. For instance, knowing that the verifier checks for uninitialized variables can remind developers to properly initialize their variables. Also, developers working with bytecode manipulation libraries like ASM or ByteBuddy need to ensure their generated bytecode will pass verification. Interestingly, some performance optimization techniques involve generating bytecode that barely passes verification, pushing the limits of what's allowed to gain speed advantages.
That's a great point about optimization techniques. It reminds me of a story I heard about a major financial institution that used aggressive bytecode manipulation to speed up their trading algorithms. They ran into issues when a JVM update slightly changed the verification rules, causing their application to fail. It really underscores the importance of understanding these low-level details, doesn't it?
Absolutely, Sheila. That's a perfect example of why developers need to be aware of bytecode verification, especially when pushing the boundaries of performance optimization. It's a delicate balance between squeezing out every bit of performance and ensuring your code remains compatible and secure across different JVM versions.
Now, as we wrap up, let's reveal the answer to our quiz question. The question was, if a malicious actor modifies a Java class file to include invalid bytecode instructions, at which stage would the JVM most likely detect and prevent the execution of this code? Victor, would you like to give us the answer?
Certainly. The answer is that invalid bytecode instructions would most likely be detected during the bytecode passing stage of verification. This stage specifically checks for the validity of bytecode instructions, ensuring they conform to the JVM specification. So any attempt to introduce invalid instructions would be caught here, preventing the execution of potentially harmful code.
Thank you, Victor. To summarize today's episode, 1. Bytecode verification is a crucial security process in the JVM that checks Java bytecode for correctness before execution. 2. It involves multiple stages: file format checking, bytecode parsing, type checking, and data flow analysis. 3. It catches issues like stack overflow attempts, illegal typecasting, and access control violations. 4. While mostly transparent to developers, understanding bytecode verification can help in writing more secure and efficient code. 5. Bytecode verification presents challenges in balancing thoroughness with performance and handling complex language features. In our next episode, we'll be exploring sandboxing and isolation in the JVM, another crucial aspect of JVM security. Don't miss it. Thank you for tuning in to JVM Internals Crashcasts. If you enjoyed this episode, please subscribe and leave us a rating. Your support helps us continue to demystify the inner workings of the JVM. Until next time, keep coding and stay curious.